Alright, we're going to start out with some basic chain rule and then we'll move into some of the more difficult ones. So for this problem, I'm going to bring the 7 down. We leave the inside alone to the 6th power. Then we take the derivative of the inside, which is 6x. I can multiply those two together without very much problem. So we got 42x times 3x squared plus 5 to the 6th. And that is our derivative. So you leave the inside alone, you use your power rule, then you take the derivative of the inside. Let's try it again with 3x squared plus 4. So in the square root, which is really 3x plus 4 to the 1/2 power. Bring the 1/2 down to take the derivative. 1/2 minus 1 is negative 1/2 times the derivative of the inside, which is 3. So 3 is really the only thing we have on top. On the bottom we have 3x plus 4 to the 1/2, or it could also look as 3 over 2 square roots of 3x plus 4. Alright, so let's take the derivative of this where we have to do more than one rule. F prime of x is equal to 5 x squared sine of x to the 4th times the derivative of the inside, but the derivative of the inside turns out to be a product rule. So x squared stays the same, times the derivative of sine x is cosine x, plus the derivative of x squared is 2x, and sine of x stays the same. There's not much we can do in this problem to simplify, so this would be my answer. Alright, we're going to take another derivative in this one. So we bring down the 3x plus 2 over x plus 4 squared. And then we have to do the product rule, or I'm sorry, the quotient rule to get the next part. So when I do the quotient rule, the top is 3x plus 2, so the derivative is 3. The bottom is x plus 4, which means the derivative is 1. I multiply these two first, and then subtract off these two. So I got x plus 4 squared in the bottom, and we have 3 times x plus 4 minus 1 times 3x plus 2. So I'm just going to simplify this over here. So we got 3x plus 12 minus 3x minus 2. Those cancel out, and so we got 10 in that box. So I got 3, and to make this 3x plus 2 squared, and then actually we should put the 3 on top, so I'm going to erase this for a second, because the 3 is on the top, times 10 from the green portion I did, divided by x plus 4 squared on the bottom from the first part, and x plus 4 squared from the second part. So all told we'll have 30, because 3 times 10 is 30, 3x plus 2 squared, and on the bottom I have x plus 4 to the 4th. Alright, we're going to try one more of these before we go on to trig ones. So when I take the derivative here, I'm using the product rule. So the derivative of the first part is 1, and then for g of x I have 3x squared plus 2x. So the derivative of that, to the 1/3 power is 1/3 times 3x squared plus 2x to the negative 2/3 times 6x plus 2, or as I simplify it, we have 1/3, the 6x plus 2 is on top, so I really don't need that 1 up there, and on the bottom I have 3x squared plus 2x to the 2/3. So x times 6x plus 2 over 3 times 3x squared plus 2x to the 2/3 plus, I multiply these two together and we just get 3x squared plus 2x to the 1/3. Distribute this x in, and I have 6x squared plus 2x over 3 times 3x squared plus 2x to the 2/3 plus 3x squared plus 2x to the 1/3. Now, in order to add fractions, I need a common denominator. And so what I need to do is I need to multiply this up here, which is easy because that's just a 1, and I need to multiply this up here. When I do that, the bottom will just be 3 times 3x squared plus 2x to the 2/3. And on the top we have the 6x squared plus 2x times 1, which stays the same, plus 3 times 3x squared plus 2x to the 2/3 times 3x squared plus 2x to the 1/3. Now when I combine these two guys together, they have the same base, so we can add the exponents. So I still have 6x squared plus 2x plus 3 parentheses 3x squared plus 2x. And I'm just doing the numerator right now because nothing's going to change in the denominator. So distribute the 3. 6x squared plus 2x plus 9x squared plus 6x. Add that and that and that and that, and we wind up with, almost finished now, 15x squared plus 8x divided by 3 times 3x squared plus 2x to the 2/3. As I was saying in class today, once we got to this point, that's the calculus. To simplify it, all of this was the algebra. Let's do a couple of trig problems. When we have this problem, we really have y equals sine of x quantity squared. So when I take the derivative, that would be 2 sine of x to the first times the derivative of the inside, which is the cosine of x, or 2 sine x cosine x. As opposed to if we would have done a problem where we had f of x equals sine of x squared, in which we take the derivative of what's outside, which in this case is the sine, so the cosine, the x squared stays the same, Then we take the derivative of the inside, which is 2x, and I generally like to write it as 2x cosine of x squared. One more, and then we'll call this a video. Let's say we have sine cubed of 4x squared, or as this would have been written, sine 4x squared cubed. So first thing we're going to do is we're going to bring down the 3 because that's on the far outside. Then we take the derivative of what's inside the whole parenthesis, which is that. Well, we have another chain rule here, so we got cosine of 4x squared. And then we take the derivative of the inside, which is 4x squared, which is 8x. So the 3 and the 8x can multiply up to be 24x sine squared 4x squared, because that's normally where we put the exponent for something like that, cosine 4x squared. And those were several examples of the chain rule.